So again, Bobo would mean bigger on bottom. The horizontal asymptote would be y is equal to 0. Bo2, which would be bigger on top, would be undefined. Again, HA stands for horizontal asymptote. And then finally you got Betsy, and that's the one that I didn't do correctly. So again, notice that this last letter is giving you what that is. All right, so Betsy, and that's the only one that you actually have to do any work whatsoever. This would be bottom equals top. And what you're going to do on here, the horizontal asymptote, is going to be the ratio of the coefficients. All right, so this is what I mean by that. All right, so let me give you an example of that. So BETC, if you have this function right here per se, so you have 5x squared, and on the bottom you have 10x squared plus 3. All right, I'm asking you, what is the horizontal asymptote of this function right here, of this function? All right, so the horizontal asymptote of this function, you're going to look at the power. What's the power on top, the biggest power? It's 2, right? What's the power on the bottom? The biggest one is also 2. So that's what I mean about being equal. So they're both equal in power. So the answer would be the coefficients, the number that are attached. Oops, this would be 1/2. The answer would be 1/2. So you basically take that number, and you take that number, and you write it down, and then you reduce it if you have to.
What happened to the 3?
It doesn't matter. It turns out that it doesn't matter. It doesn't matter what it is. All you're looking at is the powers, right? So let me go back to the front of this paper now. What, did you finish doing that? All right, so let's go to the front. So now, when you first look at the rational function, or I should say rational expression, I don't really care if you write that down, but you're going to find the greatest exponent in the numerator and in the denominator. Okay? So in each one of these, the greatest exponent is called the degree of the function. So just to give you an example of what I mean by that, if I write something that looks like this, so if I'm just talking about degrees of a function, right? So let's say that I have 3x plus 2 plus 5x squared, and I were to ask you, hey, what's the degree of this function? All you have to do is look at it. Which one has the biggest power? The x squared, right? This one has the biggest power, so this is just degree 2. It's as simple as that. If I write something like 10x to the 5th plus 13x cubed, what's the degree of this function? Right, which is the biggest power, right? So the degree are always your biggest powers. That's all I'm talking about. So you don't have to write this down anywhere necessarily, but I'm just showing you what I mean by degree of the function, all right? So from now on, when you hear me talk about the degree of the function, what I'm really talking about is what is the biggest power, okay? So let's go back to this again. So this one I'm going to write what I wrote on the front. If the degree of the numerator is greater, so that's Bo2, bigger on top. Notice that it says that it has no horizontal asymptote, or undefined is the same thing. All right. If if the degree of the numerator and the denominator are the same, so this is the one that I call Betsy, B-E-T-C. Notice that I even wrote it here. They wrote y is equal to the leading coefficient of the numerator over the leading coefficient of the denominator. All right. So, and then finally this last one, if it's bigger on bigger on bottom, that's called Bobo. If the degree of the denominator is greater, that's called Bobo. All right. So, let's really quickly look at the first one so you can see how easy this actually is. All right. So this first one right here, what's the degree of the top, the numerator? 2, right? Because this is the degree right here, the biggest power. The degree of the bottom is also 2. Now you probably would agree that those are the same numbers, right? So the bottom equals the top. So this is actually going to be Betsy, B-E-T-C. So this is B-E-T-C. And then all you have to look at, therefore, is these numbers right here, the leading coefficients. The leading coefficients means just the numbers that are attached to this variable with the power. All right, so literally the horizontal asymptote is going to be the ratio of the top number minus this bottom number. That's it. All right, so this is it for the horizontal asymptote for this one. Now, let's look at the next one, because this is actually the most work you have to do on these. On the next one, the degree of the top would be 2, right? That's x squared. What's the degree of the bottom? 1, right, because this right here would be x to the first power, right? So the degree of the top is 2, the degree of the bottom is 1. Which one's bigger, top or bottom?
Top.
The top is bigger, so if the top is bigger, we're going to do BO2, which is undefined, so the horizontal asymptote is undefined. So you can write undefined, but also that's none, or else it does not have a horizontal asymptote if that happens. So if you write this one or this one, either way, I'm happy with it. I'll give you full credit for it. All right, and the next one, what's the degree of the top? 1, right? Notice that it's not -1 because we're talking about the power, which is still positive. The degree of the bottom is 2, so which one's bigger? Bottom or top? Bottom. So this is Bobo. Bigger on bottom. Y is equal to 0 every single time. I don't really care what the numbers are. I don't care how complicated this gets. All I care about is if this power is bigger on the bottom than the power on the top, the degree of the bottom is greater than the degree of the top, it's always going to be that. Right, and finally in this last one, notice that you have the same. All right, so you have 3 and 3, degree 3, degree 3. And in this case, this is going to be one more time, B-E-T-C, Betsy. And the coefficients, in this case, the leading coefficients is going to be 4 and 2. So we have y is equal to 4 over 2, which means the horizontal asymptote is 2. Okay, do you know what a horizontal asymptote is? Maybe, maybe not. Okay. So this one's actually, I'm graphing just the top one so you can, I just at least want to show you what that looks like. So that right there, you've already done it once before. The horizontal asymptote is a horizontal line, if you will, that this function cannot cross through. All right, so as you can see, as you go left, this function kind of hugs the green line that I have here, which happens to be 3/5. All right, so this is why it looks so close to the x-axis. On the next one, this one, as you go towards positive infinity, this is actually hugging that line right there. So I shouldn't say that you cannot cross the horizontal line. Sometimes it does. But as you go farther right, this line is going to get closer to that line. And as you go farther left, this curve is going to get closer to that. That's all that means. Right? So I just want to show you graphically what that means, because that's what we're going to do tomorrow. All right, so let's go to the other set of notes. And we're not going to do all of these because the front of it is exactly the same. So this is exactly the same, so we're not going to do that part. But what we are going to do is the back, just as a reminder. So for the 7 people that weren't here yesterday, all right, this is what you would do. So to figure out the domain, so this is what we did yesterday. To figure out the domain, you're going to set the denominator equal to 0. and then solve. So on this one, you would have x plus 2 is equal to 0. And if you subtract 2 from each side, then you would get x is equal to negative 2. Okay? So now, on this one right here, therefore, my domain is going to be all real numbers except for x cannot be equal to negative 2. So it can be any number. Remember, because I cannot divide by 0. If I plug in a negative 2 here, I get a 0 on the bottom. I can't do that. Right? So x can be any number. That's what that means, all real numbers, except for x cannot be equal to negative 2. All right? So, and that turns out, for this case, turns out to be that the vertical asymptote is the same. Okay? Now, vertical asymptote, for example, if you look at this graph, the vertical asymptote is be located like right along here. That vertical line cannot be crossed, and that's kind of what happened in that. Okay? Now, what about the horizontal asymptote? What do you think? Which one's bigger, top or bottom or equal? Equal, right? So I'm going to do the ratio of the coefficients. So again, for the horizontal asymptotes, this actually would be Betsy. Bottom equals top. And on this one, it would be y is equal to 1 over 1. Now, I know you can't see a 1, but there's technically a 1 here and a 1 here if you don't see a number. Okay, so you have 1 over 1, which is 1. So the horizontal asymptote is y is equal to 1. Okay. Now on the homework, on this homework that you're doing, I'm actually also going to make you do the range. And the range sometimes can be difficult. Remember, we're talking about how far up, how far down this graph is going to go. But on this one, what we're going to say about the range is that it can be anything except for where the horizontal asymptote is located. All right. So we're going to say all real numbers except for y cannot be equal to 1. Okay. Now, this is what I'm saying right now. It's not always true, but for what we're doing right now, what we're going to do up to the end of the week, that's going to be true. Okay, so that's basically all you do. Why don't you try to do number 5, especially. I mean, if you're not here, I get it, but you still have to set the denominator equal to 0. Try to solve for that. So let me just give you a couple of minutes. Try to see if you can do that on your own. All right, so I want all of this filled out, including the range. Okay. Let's see if you can do that real fast. All right. Give you a few minutes. If you're watching the video, just fast forward through this. All right. What are factors of 3, 1 positive and 1 negative, that add up to 2? 3 and 1, perfect. All right, so what that means is that if I set each factor equal to 0, then I have one answer that's negative 3 and the other answer that's positive 1. So my domain is going to be all real numbers except for x cannot be equal to negative 3 and also cannot be equal to 1. Okay, so vertical asymptotes are going to be the same, at least in this case. Okay, now horizontal asymptotes. Which degree is bigger, bottom or top? Bottom. Great. Y is equal to 0. All right, so again, horizontal asymptotes. This would be Bobo because the bottom is bigger, so y is equal to 0. All right, so make sure you look at the notes for that I just gave you. Now the range, we're going to say the range is going to be all real numbers except for y cannot be equal to 0. Okay. Now we're going to go ahead and stop here on the notes. But if you have homework 40, make sure you